Assalamualaikum warahmatullahi wabarakatuh. So today we are going to present about age and BMI count child which is for male in Malaysia by using least square approximation. The presenter will be me, Muhammad Razi bin Abdul Aziz, Muhammad Nabil bin Azman, and also Ismail Ashraf bin Suharmain. Before we start, we are going to talk a little bit of background of study. Body mass index, which is called BMI, is a measure of body fat that is based on height and also weight. Many factors contribute to BMI, and one of them is age. Age is usually used for children because they are in a growing phase. In Malaysia, obesity is one of the main health problems that has been worried about. Malaysian Association for Study of Obesity and the Malaysian Diabetes Association are the ones that are responsible for observing the problem. They had adopted new criteria for defining overweight and also obese. The data has clarified that the cutoff points for overweight and obesity as 25 kg per meter squared and also 30 kg per meter squared. The data has been retrieved from the Ministry of Health Malaysia (MOH) that published in 2004.
Now, I would like to present step on how we find the best fit curve. There are 6 steps in find the best fit curve. First and foremost, we need to identify the model. If we want to find the linear best fit curve, we need to use the linear equation, which is y equals to mx plus c. If we want to find the quadratic best fit curve, we need to use the ax squared plus bx plus c. And then if you want to find the cubic best fit curve, we need to use the ax cubic plus bx squared plus cx plus d. Step number 2, we need to substitute the value of x and y that we had obtained from the table into the equation and then convert it into the matrix form. After we have converted into the matrix form, we now can solve by using RREF, reduced row echelon form, to know whether the matrix is consistent or inconsistent. Usually the matrix will be inconsistent, and then we need to apply the normal system formula, which is A transpose A x equals to A transpose B. While using this formula, will be obtained the determinant of A transpose A, which if the determinant is not equal to 0, therefore A has unique solution. After we solve the normal system by using ERO, we now obtain the particular function of the graph. Let we look at the data that we have collected, and we want to find the best fit curve for this data. Firstly, we look at the best fit linear curve. We obtain the function of linear equation, which is y equals to a plus bx, and then we substitute the value of x and y into the equation. After that, we point plot the point from the table. Now we want to find the linear approximation of the data, which is the first column of the data, all of it is equals to 1, and the second column of the data is represent the value of x. We put in the value of y into the matrix, and then we get this. We reduce it with RREF, then we obtain the inconsistent of this matrix. We apply the normal system, and then we find out the determinant of A is not equal to 0, which indicates A has unique solution. By using ERO to find the value of A and B, and then we obtain the function which is y equals to 17.2244 plus 0.6136x. And then we can see the graph here, which is in linear, and then we put back the point that we have been plotted earlier. And lastly, we calculate the error by using the error formula, which is b minus ax, and then we find the magnitude of error, which is 2.845. Next, we look at the best fit for quadratic curve. We use the same step as the linear, but using the different function model, which is y equals to ax squared plus bx plus c. We substitute the value of x and y, and then we put them into a matrix form, and then we reduce it by using RREF, and it will obtain inconsistent. So because of that, we use the normal system. We obtain that the determinant of A is not equals to 0, which indicate A has unique solution. And lastly, we will obtain the function which is y equals to 21.330 minus 0.956x plus 0.121x squared. And then we sketch the graph by using Maple, and then we put back the point from the table earlier, and then we calculate the error, and then we will get this answer. And lastly, we calculate the magnitude of error, and we will get 0.631. And lastly, we look at best fit cubic curve. We use the same step as the quadratic and linear. First, we need to find the function model, which is y equals to ax cubed plus bx squared plus cx plus d. We substitute the value of y and x into the equation, and then we convert the equation into matrix form, and then we will get like this. After that, we reduce by using RREF, and we will get like this. The matrix indicates inconsistent. That's why we need to use the normal system. The determinant is not equal to 0, which show A has unique solution. And then we solve the matrix by using ERO, and then we obtain the function of cubic equation, which is y equals to 23.243 minus 2.152x plus 0.329 x squared minus 0.011 x cubed. And then we will sketch the graph by using the maple, and then we combine the point from the table above. After that, we need to calculate the error and magnitude of error of this cubic curve, and then we will get like this for the error. And then lastly, the magnitude of error for this cubic function is 26.329.
And I'm going to talk about the prediction. Okay, first question of the prediction: which curve gives the best fit? Okay, we have chosen the quadratic curve as the best fit because of the least number of errors within the calculation. The other curves were not fit to be used as it is not as precise and it obtains more errors. Secondly, predict 3 points which is not given in the data. Okay, the 3 points that we have chosen as shown is because of a teenage metabolism. The teenagers' metabolism start to decrease around this time of age. As their metabolism decreases, their weight increases. So, which leads to an effect to the BMI increasing. Also, height is also a huge factor, and around this time of age, teenagers tend to have growth spurts, and when they have growth spurts, it drastically affects the BMI. And when a teenager increases in height, they would have to consume more food to balance the BMI. Age plays a huge role in both of these factors. Both of these factors increase and decrease over time. Okay, now it's time for the conclusion. This report demonstrates how the best fit linear, quadratic, and cubic curve is not as consistent. Therefore, we need an approximation because the degree to which weight and height vary. And it correlates with each other differences between sexes and changes across age and time. So, a lot of things have to be put in consideration, especially weight and height. Firstly, people grow taller over time. Height affects the BMI to a certain degree, and one would have to weigh more if they are higher, if they are taller. For example, it is previously reported in increases in childhood overweight and obesity in Australia between 1985 and 1995, and were likely to be moderately overestimated as a result of increased population height, suggesting that population height can be taken account in any pediatric investigation of changes in overweight obesity prevalence over time. Also, a human's metabolism affects weight drastically, and that changes over time. As someone gets older, the metabolism usually decreases. Although it is different for any other human, this is usually the case for most humans. It doesn't matter the sex, it is the same for any human and animal.